Okay, this is Algebra 2. We're looking at matrix equations today. The first thing we're going to learn how to do is how to write a matrix equation for a system of equations. Remember, a system of equations is just two or more. So the first thing you have to do is figure out the coefficient, the variable, and the constant. So you're going to take one matrix, and it's made of your coefficients. So you have A, B, C, D. So 3, -7, 1, because there's not a number in front of x, and 5. You got to make sure and put a 1 if there's not a coefficient, and you've got to put the correct sign. Then it's going to be times, and your next matrix is just going to be your two variables, x and y. Go from left to right. Equal, and then your constant is just going to be what they're equal to, 12 and -8. And that's all you have to do. If it is a 3 by 3, you're just going to use x, y, and z. But it's the same basic setup. So looking at number 1, you're going to have 2, 1, 5, -3 in your first matrix, times x over y for your second matrix equals 8, -12. And that's all you have to do on this first part. It's just saying, can you turn a system of equations into a set of matrices? And that's all you have to do. So number 2 would be 4, -3, 1, 2 times x, y equals 18, 12. Number 3 would be 7, -2, 3, 1 times x, y equals 15, -10. And you think, well, there's nothing to that. Well, that's right. I'm easing you into this. That's just the first step of what we're going to do in a little bit. So that's pretty easy, pretty straightforward. Now they want you to go the other way. Or not. Sorry, more of the same. It's just that these are going to be 3 equations. So we're going to have 2, 1, 7, 5, -1, 3, 1, 2, -6. One thing that is important is that you get each of your equations in the same order. You want it to be x and then y and then z for all of those. So this is going to be times x, y, z equals 12, 15, 25. So for the last one here, we're going to, oh, this is what I was talking about. They're not in the right order. So I'm going to bring my x and my y over here. I'm going to have 3x minus 2y plus z equals 45. I'm going to have 2x plus 3y minus z equals 60. You wouldn't have to rewrite that one, but it's okay if you do. I'm going to have x minus 4y plus 2z equals 120. What you're doing is you're moving everything to the left and you're getting order x, y, and then z. So now we can do this. And we have 3, -2, 1, 2, 3, -1, 1, -4, 2. Times, we have x, y, z equals 45, 60, 120. Okay, so setting it into matrices is really not that difficult. So moving to page 2. This is where you're going to actually use that matrices equation, basically, that you set up to actually find the solution. Okay, so here's the deal. When you're solving, if ax is equal to b, then x is the inverse of b, where a is the coefficient. Doesn't make a whole lot of sense, right? What you want to do is they're going to give it to you right here as a matrix. What you do is you find the inverse of the coefficient or the first matrix. This is what we learned on yesterday. You added the formula to your note card possibly, but you may or may not have that note card with you. So let's take a minute and put that formula on this paper. 1 over AD minus BC times D negative B negative CA. Okay, remember that's what you multiply by to get the inverse. That's how you get the inverse. And so this would be A, B, C, D. Notice that I'm letting you make note cards. I'm letting you write this formula down. It's a confusing formula. It's something we don't use all the time, so I will let you have it written on a note card or on your review or on your paper for anything we do in this unit. So what they did was they said 1 over AD minus BC, which meant 20 minus 12, okay? So that was where their 1 over 8 came from. And then they rewrote these. D was 4, negative B is negative 2, negative C is negative 6, and A is 5. So then this is the inverse. You found the inverse. You multiply each side by the inverse. So we wrote it here, and we wrote it here, once on each side. Now, if you multiply a matrix by its inverse, you're going to end up with the identity. We learned this yesterday. That's the whole purpose of the identity. So when I multiply this right here, okay, the inverse times that matrix, I get the identity, 1, 0, 0, 1. And then right here, they wrote that in front. They're going to want to take these two and multiply, and then you get this new matrix. Then you take each element of that times your 1/8, which is where the 2 and the negative 2 came from. So your final answer is that x is equal to 2 and y is equal to negative 2. And it's going to make a whole lot more sense when we actually do a problem. So let's look at this, and let's start by figuring out that this is A, this is B, this is C, this is D. And so we've got to find the inverse, remember? And so the inverse is 1 over AD minus BC. So that would be 5 times negative 8, which is negative 40. Maybe we should do this in the calculator. Negative 40 minus C times B, which is 36. So I get a negative 76. So that's 1 over negative 76 times D, which is negative 8, negative B, which is going to become negative 4, negative C, which becomes negative 9, and A, which is 5. So 1 over negative 76 times negative 8, negative 4, negative 9, 5. That's your inverse. That gets multiplied by both sides. Okay? So you're going to have that times, and the left side is going to be your coefficient matrix, 5, 4, 9, negative 8, times your variables, x, y, equals, you've got all of this stuff again, and I'm running out of room. 1 over negative 76 times all of that stuff that I really don't have room for, times 5 and 0, okay? Because that came from the right side of the equation. Okay, so basically, all of this and this came from the equation. And then the other stuff is just your inverse. This is actually your negative 8, your negative 4, your negative 9, your 5. I just didn't have room to write it all. Okay, so when you multiply this, if you multiply the inverse by a matrix, you get the identity. So it's always going to become 1, 0, 0, 1. We still have our times x, y. And here we're going to actually have to multiply. We've got to figure out what it is. My suggestion is you multiply this first. We still have 1 over negative 76 times, you got to think back to last week when we multiplied, and it's row 1 times column 1. Remember, this is a 2 by 2. This is a 2 by 1, so you can do it, and it's going to be a 2 by 1. So row 1 times column 1, negative 8 times 5, minus negative 4 times 0 is negative 40. And then row 2 times column 1, you have negative 9 times 5, minus 5 times 0 is negative 45. So then, if you multiply this, I mean, you could go through and do it, but I'm just telling you so that you can save steps. Anytime you multiply it by the identity, you're going to get the same thing. So we're going to have x and y. equals, and here you're just going to say 1 divided by negative 76 times negative 40, and you get 0.526. And then you're going to say 1 divided by negative 76 times negative 45, and you get 0.592. So your final answer, x is equal to 0.526, y is equal to 0.592. Okay, if you think back to when we did systems of equations, we solved by substitution, we solved by elimination, we solved by graphing. Okay, now you can solve using matrices. Not saying it's always the fastest, easiest way, it's just one more thing. It's kind of one of the purposes of matrices. So on number 2, we're going to start by figuring out the inverse. So this is going to be 1 over AD minus BC, so negative 12 minus negative 2 becomes negative 10 times, and then you're going to say D, which is, no, it's D, which is negative 4, negative B, so that becomes a positive 2, negative C becomes a negative 1, and A is 3, times x over y equals, and we're going to put the inverse again, so 1 over negative 10 times negative 4, 2, negative 1, 3, times 5 over 20. So this is going to give you the identity. So 1001 times xy equals 1 over negative 10 times row 1 times column. Negative 4 times 5 plus 2 times 20, which is going to be 20. Negative 1 times 5 plus 3 times 20, which is going to be 55. So when you multiply each of those times negative 10, you're going to end up with x is equal to negative 1/10 times 20, which is negative 2. And y is equal to negative 1/10 times 55, which is negative 5.5. And so that would be your solution. Moving to the next page. Looking at number 3, I'm probably going to run out of time. This is going to turn into 2 videos. You're going to say 1 over 3 times 4 is 12 minus 5 times 2 is 10. So 1 over 2 times 4, negative 2, negative 5, 3 times x, y equals 1 over 2 times 4, negative 2, negative 5, 3 times 3, negative 7. So you're going to end up with your identity, 1001 times x, y equals 1/2 times 4 times 3 is 12 plus 14. So you're going to have 26. Negative 5 times 3 is negative 15 plus negative 21, negative 56. So x is equal to half of 26 is 13. Y is equal to half of negative 56 is negative 18. And that's your answer. Looking at number 4, you're going to start with 1 over 2 times 5 is 10 minus 6 minus negative 6, and so that becomes positive 16. You're going to say 5, 3, negative 2, 2 times, and I really haven't been writing, but technically it's times 2, negative 3, 2, 5 times x, y equals all of that 1 over 16, 5, 3, negative 2, 2 times 4, negative 8. Because really, this is what gives you your 1001. Okay, that's where your identity comes from. Times x over y, not over, sorry, ignore that line, equals 1 over 16 times, I'm going to go ahead and pause this right here, and then we will pick up at this point on the next video.